Hi everyone, Gregor Card here, and in this video we're going to be talking about the filters in Betaflight, what they are, what they do, and why we need them. To understand why we need filters, we need to learn a little bit about how the gyroscope, or gyro, works. The type of gyro in your drone is likely a micro-electro-mechanical system, or MEMS gyro. A MEMS gyro uses microscopic resonating masses to measure angular velocity on 3 different axes. These masses produce an analog signal that then gets sampled into digital information that is then read and used in the PID loop. The rate at which the gyro information gets sampled is the gyro update frequency. You can choose what the sample rate will be in your flight controller software, commonly set at 2K, 4K, or 8K, meaning 2,000, 4,000, or 8,000 samples per second. Generally, a higher sample rate is desirable, but depending on how you set up your flight controller, it might be beneficial or required to lower the sample rate. Like if you're using RPM filtering, you will need to set the sample rate depending on the speed of the flight controller processor. So basically, the gyro on your drone is a key component that very accurately senses the angle of your drone on 3 different axes. The problem is, because it's so sensitive, it's susceptible to noise. When you think of noise, normally you think of audio noise, like if you're in a noisy environment like a busy restaurant or a crowded sports arena. The noise will make it hard to communicate. On your drone, the kind of noise we're talking about is mainly vibrational. You have a rigid frame with 4 motors spinning props at high speed, constantly changing RPM and wind resistance. All that adds up and creates vibrational noise on the drone. Also, if a motor or prop is not balanced, it will cause vibration that the gyro will pick up, causing it to send noisy data to the PID loop, which will make your drone's maneuver sloppy. That's where filters come into play. Most everyone knows what a filter is, like a coffee filter, an oil filter, or a water filter. They are for filtering out impurities or unwanted material. The gyro on your flight controller sends out electrical signals to the PID loops. This signal needs to be cleaned for the PID loops to accurately make its calculations. So the job of the filters is to filter out the bad noise caused by vibrations and let the good gyro data through. In your flight controller firmware, there are several different filters that work on eliminating noise coming out of the gyro so that the PID loops can focus on just the movements of the drone. Let's talk a little bit about how these filters work. The filters filter out vibrational frequencies within a specific range. Let's say you were listening to music and there were a lot of really high-pitched sounds that were hurting your ears. Well, you can turn the treble down on your stereo to filter out that high-pitched sound. The high frequencies get attenuated or blocked, but you can still hear everything else in the mid and bass range. The 2 main types of filters on your drone are static and dynamic filters. Static filters are basically set to certain frequencies and are meant to block out noise in a preset range. Dynamic filters are able to dynamically adjust to changing conditions. Like when you raise and lower the throttle, the filter can adjust to the different frequencies of motor vibration caused at different motor RPM. There are different variants of both static and dynamic filters, notch and low-pass filters. A notch filter attenuates or blocks noise in a specific frequency band called the stop band frequency range and passes signals above and below this band. A dynamic filter is very effective at targeting specific noise sources and reducing them to clean up the gyro signal. A low-pass filter passes signals with a frequency lower than a selected cutoff frequency and attenuates or blocks signals with frequencies higher than the cutoff frequency. So it is a lot like what we said earlier, turning down the treble on your stereo. Depending on where it is set, it will block the higher frequency noise while allowing the lower frequency signals to pass. So now we have a basic understanding of how and what filters are, but how and why do we want to adjust them on our drone? Well, if we go over to Betaflight, we can take a look at the filter settings under the PID tuning tab. We see here that we have several different filters with a bunch of settings. The Betaflight developers recommend that we leave most of these settings alone and just use the sliders to make our filter adjustments. Before we do any adjusting to the filters, it's recommended that we get RPM filtering set up first. We will show you in the next video how to set up RPM filtering. Now it's important to note that too much filtering can be a bad thing. If we have too much filtering, it can slow down the response time of the PID loops and actually make your drone fly worse. Just like if we put too dense an oil filter in our car, not enough oil could get through when it is needed and would make your car perform badly. The less filtering you have, the better the latency on the PID loops will be. So the goal is to have the least amount of filtering and still have your drone flying great with the least amount of prop wash. However, with that being said, too little filtering can also be dangerous. It can cause anything from runaways to burning up your motors. So while adjusting your filtering, it's best to do it in small increments. You can make an adjustment by moving the sliders 2 notches to the right. Click Save, and then go out and test fly, checking motor temps very often. To check the motor temps, simply fly for about a minute, land, and then pinch 1 or more of the motors with your fingers. Generally, if it's too hot to hold with your fingers, it means that your motor is overheating. If your motors are cool to warm, you can go 2 or more clicks to the right and repeat the testing process. You will just need to be very careful while doing this. If you fly for a minute or less, land, and your motors are too hot, you may want to move the sliders 1 click to the left to be on the safe side. If you hear any strange sounds like grinding or strange whining from your motors when you arm and take off, stop flying immediately. This means that you have set your filters too low. You'll also want to make sure when adjusting filters to stand back from your drone when arming. With too low of filtering, a runaway or flyaway can happen. This is when you arm your drone and it immediately jumps into the air uncontrollably. You must quickly disarm to prevent burning a motor. Adjust your filter settings back over to the left 1 or 2 notches, then test again. Now don't let this scare you. Normally, hot motor temps will be the first indication that your filtering is getting too low. Just be careful and adjust in small steps until you find the right balance between drone performance and motor temps. Remember, it's not required to adjust your filtering. It's okay to fly with stock settings. But for those that want to get a little bit better performance out of their drone to improve their flying experience, it's worth the effort. As always, if you have any questions, definitely let us know and have fun flying.